Do you know?
Not really.
Okay. This question says a parallelogram ABCD has side lengths 35 centimeter and 27 centimeters. Okay. A parallelogram, let's see if I have a specific shape, can be many different shapes. Okay. In fact, all it needs to be is have parallel sides. So they usually look something like this. Okay. So this could be a parallelogram here. But let's also point out that this could also be a parallelogram. Technically, this square could be a parallelogram. And I'm going to try one more time to make this type of a rhombus. A rhombus is an angle where they all the same size. Okay, and what we're going to do is talk about these. So, in a square, all four sides are the same. In a rhombus, technically, all four sides are the same. They just don't have right angles to them. Okay. In a rectangle, we have two sides the same, two other sides the same, but there is a 90-degree here. And here we have two sides the same, two sides the same. The only difference is we don't have 90-degree angles. Okay. And what's very important, this gives you side lengths. This type of thing, okay, that tells you that things are parallel. Okay. So we're just going to go like that. So we know those are parallel. These sides are parallel. I know these are parallel. And these are parallel. See, it shows that all of these are parallelograms. Okay, that's what it's telling us. That's what those symbols mean on the geometric shapes. Now, what they said in the question was that one of the sides was 35 and one of the sides was 27. So right away, that tells us it can't be a square because the sides aren't all the same, and it can't be a rhombus because the sides aren't all the same. Okay, but we do have an option in one of these two shapes. It also says that the contained angle is 130 degrees. Well, in a rectangle, what are all angles?
90.
So it can't be a rectangle either. So this is the type of parallelogram we're looking to work with. We know one side is 35. We're going to call it this size because it looks like it's longer. Did it say centimeters? Yeah. And this side is 27. And then, obviously, whoops, centimeters. The opposite sides are the same length. We're going to call it A, B, C, D. And they said a contained angle was 130. Well, looking at these, this type of angle here is acute, right? So could that be 130 degrees? Mm-hmm. No. It's got to be less than what?
90.
Yeah, that's right. It's got to be less than 90. Can this one be 130? Yeah. Okay. So that'll be 130. Which means what will the opposite one be?
50.
This one here?
Yeah, 130.
Yeah, they'll both be the same. And good. What will this one be?
50.
How did you know that?
Subtract 130 from 180.
Yeah, good. Okay. Technically, in a parallelogram, or any four-sided shape, any of these, all the corners add up to 360 degrees. Okay? And we know that our corresponding sides are going to be 180 each. So that's great. You've discovered all the angles in here. That's good information. Now, what it says is the length of the longer diagonal is what? And they've given you many options. Well, let's talk about the diagonals. So there is diagonal 1 in blue and diagonal 2 in green. Which of these is the longer diagonal?
They're both the same. Or the blue one?
The blue one. In a rectangle, they'll both be the same, right? But the blue one is definitely the longer angle here. Okay, I know it can be a little tricky to look at first, but because these distances here are nice and long and it's tilted on that edge, it's going to take us longer to get over here. And what they've now done, okay, is they've given us a triangle. Okay, so we're going to highlight our triangle here. We'll do it in green, actually. So here's our triangle that we're now working with. Now, inside the triangle, we have a 130-degree angle. Okay. And we have measurements of two of the sides. The other side down here is 35 centimeters. Now, this is a diagonal, so we can probably figure out what these corners are going to be, because diagonals tend to slice things in half, right? But let's just say we're not 100% certain about that. We have this here, and I'm going to put it in red just so it's a little more prevalent now. We wrote on top of it. Okay. We're trying to find the what of this side?
The length.
The length. Okay. So we have two lengths for sure and one angle. Do you know what formula we could use to solve this?
sine law.
Okay, let's try set up sine law. Jump down. Our sine law states, and I'll just quickly recreate the triangle down here so we have a better reference point. That'll be fine. I'll just flip. There we go. Right. So let's reference this again. This was 35, though it doesn't quite look it in the one I made. And this is 27, right? And that is 130 degrees. Sine law states that sine A divided by side A is equal to sine B divided by side B is equal to sine C divided by side C. So how do you want to name this triangle? Does it really matter so far? No. Okay, so let's just put it up here. We'll call this A, B, and C, which makes 27 what side? 35 is
C.
And the one we're looking for is B. Okay, so let's try to plug information we have in. Okay, sine A, well, we don't have the measurement, so it's sine A divided by 27 is equal to sine B. Well, we have that. Sine B is 130, but we don't have the side. And sine C, we don't have the angle, but we do have the measurement of the side, which is 35. Now, in order to use sine law, we need a complete ratio. Are any of these complete ratios? No. So can we use sine law to solve for this side B? No. Like I said, if we did have this information, these angles, we technically could. Okay, but let's say we don't. So what law do we actually have to use then? It's a non-right angle triangle. Yeah, cosine law, which is c squared is equal to a squared plus b squared minus 2ab cos c. Okay. Now, the only downside for cosine law, when we go to name the triangle, do you know the trick? What's important about my side C and angle C?
Switch it to B.
Yeah, it needs to be the side we're looking for. So we're going to rename the side B and angle B to C. Okay, just so they set up. And that's fine. We can rename triangle any way we really like. So this will be our BB. This will be angle C, side C. So now we got to plug in the cosine law and see what we get when we do this. Side C, well, that's unknown, is equal to side A is 27 squared plus side B is 35 squared minus 2 times A, which is 27, B, which is 35. And cos, how many degrees?
130.
All right. Now, how many variables are left in this question now?
One.
Just one. Which means we can solve for it. Okay? So let's kind of go through this process together. Get your calculator out. First thing we're going to deal with is 27 squared, 729. Okay? So we know c squared is equal to 729. What's 35 squared?
1,225.
Great. Negative 2 times 27 times 35.
Negative 1890.
Great. And times cos 1/3. We'll leave that as is, I guess. Okay. We'll continue to simplify. What's 729 plus 1,225?
1954.
Good. Minus 1890 times cos 130. Alright? What is cos 130?
Negative 0.64.
Negative 0.64. Let's go to 4 decimal places with it.
7.
27. Great. Now what's the next step?
Multiply 1890 by the cos.
Yeah. Positive or negative 1890?
Negative.
Good. So what are we going to get?
So 1,000
Positive or negative?
positive.
Yeah.
1,214.
14. Great.
0.4.
Okay. Let's keep going with what we got. Add those together.
There's 3,168.
All right, are we done?
And
What do we have to do?
yeah, there's find the square root.
That's right, because this is squared, we square root both sides. Side C is equal to what?
56.
56? Point something or just 56?
0.29.
Okay. We'll say approximately 56. So is there an option?
Yeah.
It says 56? Yeah, 56.3. Great, we were at 56.29. So the answer to that would be our B. Next question. Does that make sense? What we
Yeah.
did? Quite a bit of work, eh?